Hello and welcome. I will be answering JAMB 2010 Physics Past Question 34. 3 capacitors of capacitance 2 microfarads, 4 microfarads, and 8 microfarads are connected in parallel, and a potential difference of 6 volts is maintained across each capacitor. The total energy stored is A. 6.90 times 10 raised to the power minus 6 joules, B. 6.90 times 10 raised to the power minus 4 joules, C. 2.52 times 10 raised to the power minus 4 joules, D. 2.52 times 10 raised to the power of minus 6 joules. So you have 3 capacitors, okay, of these capacitance connected in parallel, okay, and we are given the potential difference and asked to calculate the total energy. Now, the first thing to do will be to calculate the total capacitance. And total capacitance for capacitors connected in parallel, C is equal to C1 plus C2. Okay, in this case you have 3, so C1 plus C2 plus C3. Okay, so for as many capacitors as you have, as long as they are connected in parallel, to get their total capacitance, all you need to do is just to add them up. So in this case, that is 2 plus 4 plus 8, which is equal to 14 microfarads. Okay, so the potential difference is 6 volts. Okay, let's say V, voltage potential difference. Now the energy is equal to half CV square. Okay, so now this is equal to 1 over 2 multiplied by 14. Now we need to find our answer in farads. We need to convert it to farads. So to convert from microfarads to farads, if you do that, what you have is 14 times 10 raised to the power of minus 6. That's how you convert to farads. Okay, multiply by 10 to the power of minus 6, then times 6, the potential difference, 6 square. So all these together will give you 2.52 times 10 to the power of minus 4 joules as the energy stored. So that is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.